Hello and welcome back to Effective JaRu, the series where we read effective Java and try to apply idioms and paradigms learned here to idiomatic Rust. Not always possible though, and sometimes kind of you wouldn't ever want to do that. So use interfaces only to define types in item 19. So apparently I didn't know that actually. I mean, there's lots of stuff I don't know about Java, but I wasn't aware of that an interface can also contain data, right? You can add data to an interface. I'm not sure if this also holds true for instance members or only for static ones, for type members. So as an interface is supposed to add some functionality to a class, in that case, I always want to say type, which seems to be a bit more general to me. These ones that don't have a single method defined here would not satisfy that requirement. Well, so don't do that. Don't define interface just because you pollute the namespace of other people that happen to derive from someone who implements this, even though it's not really an interface. It's a bit of a misuse, really, of an interface. So instead, you're supposed to, guess what, create a class that you cannot instantiate and then put your statics there. Very, very interesting, because it seems quite cumbersome. Even that seems like a workaround, because you are not able to just put this stuff here. I mean, come on. Can you put this stuff there? Let's see. I shall just try to run this, to compile this. And it doesn't like it because error class interface or enemy expected. Yeah, you can't do it. And that's a language design flaw, if you ask me. Once again, you have to put everything in a class which is totally arbitrary, which is totally weird, which leads to weirdnesses like this. Because in Rust, what would you do? First of all, trait physical constants, they cannot have data. So you cannot do this at all. You cannot, I wouldn't even know how to do this. You couldn't say foo is an F64. You can't initialize it. All this is just, lights up red for good reason. It won't work. So you never put data in any way to a trait, which doesn't traits have a certain purpose. You are supposed to define functionality and types and relationships between these types, but not more. Data is all part of the implementation of the respective type. So I wonder if it's possible, if you have a private interface, so that should be package private here, foo. And now let's see if we can add a public static final. That should work. But what about one that is not static? What about an instance thing? Does that work? I think it shouldn't work. Oh my god. So interfaces allow you to add data to your type. Whoa. So this is why it says you pollute the namespace of everyone implementing it, because apparently you can access it directly then. If you're implementing the interface, then you can just say, well, electron mass, right? Whoa. Okay. So that's, I think, a super bad thing. Why? Yeah, actually, why? Why is it super bad? I just think that functionality has nothing to do with the data underneath, and that interfaces should abstract that away. This is why they are there, but in Java they don't. Whew, that's very interesting. So I would consider an interface flawed if there's any data associated with it. May it be statics that are basically shared across all instances and are therefore global to the program, or even worse, if it's an instance variable or an instance member here. Yeah, so that's terrible. I did compile that, yeah, and it did actually work. Sure. It did actually work. Sad. Yeah, that's quite terrible. So you will not be able to do this. If you want to have a representation of these physical constants here in Rust, you would just have it like this. We can have a submodule just for the fun of it. Obviously, that's not technically required. And then we would have a pub const, yeah, a pub const, whatever that is. Let's make an F64. Pub const F64. And probably you would also bring in the type in there somehow into the name of it. Actually, if you do that, we might as well make it a real comment. Like this, F64, pick that one up. So that would be what you would do in Rust. And then the moment you wanted to use this, we could, we could hide this and only do this when we are testing stuff. Then you can basically use super. Oh, actually, that shouldn't be capitalized. The linter would have told me constants, everything, and now we can use the Boltzmann whatever constant const use here and do some computation with it, whatever that would be then, huh? But that should show how it can be used. What? Yeah. Apparently you have to make an assignment even though you want to discard it. So that's constant item is never used. Well, we could also multiply it by the electron mass just to show how it can be used. So I could use the constants module directly. I can also import everything. That's totally up to me. In Java, it seems something like that was recently added in Java 1.5. Well, Java 1.5 is not recent. But it's static imports, right? So use of static import to avoid qualifying constants. So this allows you to pull in statics from a class of any kind, which makes the class a namespace technically, right? And that seems like a feature that people wanted to add because it makes sense to be able to do that, even though to me it's a bad thing to have added this because now a class is a namespace, even though it's a class, right? And special handling, only the statics are imported. Yeah. In Rust, you can do this too with enums, for instance. In that case, enum acts like a namespace too. So, for instance, if you want to have an enum here, yeah, I'm asking myself, can I initialize constants with a value? I don't think so, huh? I don't think that will work. That shouldn't be, I mean, maybe it is valid. I've never done that for some reason. Okay. Found F32. Expected ISO. So this assignment only works for ints then. Unless you, can you do this? Like initialize a tuple with that? No, that doesn't work either. See, okay, so you can assign ints, which is probably useful if you want to have a standard C style enumeration constant or enumeration, but usually you wouldn't do it that way. Anyway, long story short, you you can import these names, but these serve as constructors now. That's more like a factory that allows you to create one of these enumeration variants. And obviously you can, well, you can import these as well, like so. Use super constants, voila, and now you can just use it directly. Like, okay, let's get a Boltzmann here. That should work, and it does. Yeah, so that's kind of the import rules for enums and for modules in general in Rust. And generally, traits will not allow you to have any kind of any kind of data. Let's document this here. Traits cannot have any cannot have data fields. Whereas in Java, you can enforce static as well as instance fields. So fields, I think it's clear that these carry data, and I would actually never do that. Yeah, that is that. I think that definitely concludes this particular topic. So thanks for watching and have a great day.